Okay, let us continue. 好，让我们继续。Figure 4.16 shows the Doppler spectrum based on equation 4.35 for 2.4 GHz and 5.25 GHz。那么图4.16呢，就秀出了2.4个10亿赫兹以及5.25个10亿赫兹的时候基于方程式 4.35 的都普勒频谱。Okay, let us look at figure 4.16. 好，让我们看到图4.16。Figure 4.16 shows the Doppler spectrum used in IEEE 802.11n。那么图4.16呢，就秀出了在 IEEE 802.11n 里面所使用的都普勒频谱。The x-axis is f minus fc from minus 30 to 30 Hz。那么横轴呢是 f 减 fc， 从-30到30赫兹。The y-axis is the Doppler spectrum from minus 35 to 0 dB。那么纵轴呢是都普勒频谱，从-35到0 dB。And the dashed line is for Fc being equal to 2.5 GHz。那么这条虚线呢是代表 Fc 等于 2.5 个10亿赫兹。Okay, this curve 好，就是这条曲线。And the solid line is for Fc being equal to 5.25 GHz。那么黑色这条实线呢是代表 Fc 等于 5.25 个10亿赫兹。Okay, this curve 也就是呢这条曲线。Okay, let us look at equation 4.35。好，现在呢让我们看到方程式 4.35。Okay, this equation 就是这个方程式。The contrast between this indoor spectrum and the Clark spectrum is dramatic。那么这个室内的频谱呢，跟克拉克频谱之间的对比是非常的戏剧性的。Okay, let us look at the indoor spectrum。好，让我们看到这个室内的频谱。Okay, this figure 就是这一张图。And let us look at the Clark spectrum。接下来呢，再让我们来看这个克拉克频谱。Okay, this is the Clark spectrum。这个就是克拉克频谱。You can see that the contrast between these two spectra is dramatic。你可以看到呢，这两个频谱之间的对比呢是非常的戏剧性的。Okay, next, let us see the general Doppler power spectrum。那么接下来呢，让我们来看看一般的都普勒功率频谱。In this section, we discuss the Doppler power spectrum in its most general sense, and explain how it is related to phi c of delta t, delta f, defined in equation 4.27。那么在这一节当中呢，我们要讨论的是都普勒功率频谱，以一个它的最广义的形式来讨论，并且解释呢这个都普勒功率频谱是如何跟方程式 4.27 所定义的 phi c of delta t delta f 扯上关系的。 Okay, let us see equation 4.27. 好，现在让我们看到方程式 4.27. Okay, this equation 就是这个方程式 phi c of delta t f1 f2 becomes phi c of delta t delta f. 那这个 phi c 呢 delta t f1 f2 呢变成了 phi c of delta t delta f, where delta f is the difference between the two frequencies f1 and f2. 其中呢，这个 delta f 是两个频率 f1 跟 f2 之间的差。Okay, and this is equal to the Fourier transform of small phi c of delta t tau. 那么这个大 phi c of delta t delta f 呢，是等于这个小 phi c of delta t tau 的傅立叶转换。Okay, please note that the variable is tau. 请注意呢，这个变数呢是 tau. And what is small phi c of delta t tau? 那什么是这个小 phi c of delta t tau 呢？ Okay, let us go back to the previous slides. 好，让我们回到前面的投影片。Okay, phi c of tau, phi c of delta t, tau 1, tau 2. 好，这个 phi c of delta t, tau 1, tau 2呢 is equal to 1/2 times the expectation of square of absolute value of c of tau. 那么就等于呢1/2的 c of tau 的绝对值平方的期望值。Okay, where phi c of tau is called the multipath intensity profile, the delay power spectrum, or the power delay profile of the channel. 那么这个 phi c of tau 呢，就称之为多重路径强度剖面图，或者是延迟功率频谱。或者是功率延迟通道的功率延迟剖面图。And c of tau is the impulse response of the channel. 那么这个 c of tau 呢，就代表我们通道的脉冲响应函数。Okay, the general definition of the Doppler power spectrum, which we denote by SC of nu delta f, is as follows. 好，那么这个都普勒功率频谱一般的定义呢，我们把它记为 SC of nu delta f 就如下所示。SC of nu delta f is defined as the Fourier transform of phi c delta t delta f with respect to delta t. 那这个 SC of nu delta f 呢，就定义成 phi c of delta t delta f 的傅立叶转换。那这个傅立叶转换呢，是针对 delta t 这个变数进行傅立叶转换。If we consider a single transmit frequency, 如果我们考虑一个单一的传送频率的话 then delta f is equal to 0 and the Doppler spectrum simplifies to. 那么 delta f 就等于0，然后都普勒频谱呢就会简化成 SC of nu is defined as SC of nu delta f being equal to 0 and is the Fourier transform of phi c of delta t with respect to delta t. 好，这个 SC of nu 呢就定义成 SC of nu，然后 delta f 等于0， 就是 phi c of delta t 的傅立叶转换。那注意一下呢，傅立叶转换是针对 delta t 这个变数进行傅立叶转换。Where nu in this equation is equivalent to f minus fc in our earlier discussion。那么在这个方程式中的 nu 呢，就等价于我们先前所讨论的 f 减 fc。This implies that the Doppler spectrum is the Fourier transform of phi c of delta t, which is called the space-time correlation function. 好，那么这个意味着呢，这个都普勒频谱就是 phi c of delta t 的傅立叶转换，那么称之为呢空时相关函数。We depict this Fourier transform pair relationship in Figure 4.17. 那么我们把这个傅立叶转换对的关系呢，描绘在图 4.17 当中。Figure 4.17 shows the relationship between the space-time correlation function and the Doppler power spectrum。 那么图 4.17 呢，就秀出了空时相关函数和都普勒功率频谱之间的关系。Okay, this is the space-time correlation function。 这是空时相关函数。The x-axis is delta t。 那么这个横轴呢，就是 delta t。And the y-axis is phi c of delta t。 那么纵轴呢，就是 phi c of delta t。 And the width of the phi c of delta t is tc。 那么这个 phi c of delta t 的宽度呢，就是 tc，where tc is the coherence time。 其中呢 tc 就是同调时间。 And this is the Doppler power spectrum。 那么这个呢，就是都普勒功率频谱。 Where the x-axis is nu， 其中呢横轴是 nu，and the y-axis is sc of nu。 那么纵轴呢，就是 sc of nu，and the width of sc of nu is bd。 那么这个 sc of nu 的宽度呢，就是 bd，where bd is the Doppler spread。 那这个 bd 呢，就是都普勒扩展。 And these two functions form a Fourier transform pair。 那这两个函数呢，形成一个傅立叶转换对。To see that the relationship in equation 4.37 makes sense from an intuitive standpoint, consider the case where the channel is time invariant。 那么为了要看到在方程式 4.37 中的关系，如果从一个直观的观点来看是合理的话呢，我们现在考虑一个情形，就是通道是非时变的。Okay, let us see equation 4.37 again。 那么现在呢，让我们再度的看到方程式 4.37。 Okay, is this function 就是这个函数is this equation 就是这个方程式。Under that assumption, there are no dynamics to create Doppler broadening, so we should expect the Doppler spectrum to be a delta function。 那么在那个假设之下呢，没有任何的动态的现象呢，能够在频谱上创造出都普勒变宽的这个现象，所以我们应该会期望呢，这个都普勒频谱会是一个 delta 函数。 For a time-invariant channel, the frequency response of the channel does not change with time, so phi c of delta t is simply a constant for all values of delta t. 那么对于一个线性非时变的通道呢，这个通道的频率响应并不会随着时间而改变，所以 phi c of delta t 呢，只是一个很简单的常数对于所有的 delta t 的值。Okay, this implies that the Doppler spectrum Sc of nu is equal to delta of nu, which then implies that BD is equal to 0, as we would expect. 所以这就意味着呢，这个都普勒频谱 Sc of nu 等于 delta of nu， 那么就意味着 BD 等于0，那正如我们所期望的。Okay, because Sc of nu is the Fourier transform of phi c of delta t. 那么因为这个 Sc of nu 呢是 phi c of delta t 的傅立叶转换， so the Fourier transform of a constant is the constant times a delta function. 所以呢，一个常数的傅立叶转换呢，就等于那个常数乘上个 delta 函数。And BD is equal to the width of Sc of nu. 那我们知道呢，这个 BD 是 Sc of nu 的宽度。Okay, here BD is the width of the Sc of nu. 好，就像这张图所示 ，BD 是 Sc of nu 的宽度。And for a delta function, the width of the delta function is equal to 0. 那么对于这个 delta 函数而言呢 ，delta 函数的宽度是等于0， so BD is equal to 0， 所以呢 BD 就等于0。Okay, next let us see section 4.4.4.2 coherence time TC。那么接下来呢，让我们看到 4.4.4.2 节同调时间 TC。The coherence time is the maximum time that can elapse between transmitting two identical signals and there still being a high probability that the received signals will be highly correlated. 那什么是同调时间呢？就是说我现在传送两个一样的信号，然后呢仍然有一个很高的几率，那什么很高的几率呢？就是接收到的信号有两个信号会是呢高度的相关的。那么传送这两个一样的信号呢，所经历的时间的最大值就是所谓的同调时间。Clearly, if the channel is varying slowly, the coherence time will be large and vice versa. 那么很清楚的，如果通道变化的缓慢的话，那么同调时间呢就会是大的，反之亦然。Okay, what does vice versa mean? 这个反之亦然的意思是什么意思呢？Okay, it means that if the channel is varying quickly, the coherence time will be small. 那意思就是说，如果通道变化的是快的话呢，那这个同调时间就会变小，就会是小的。Since slowly varying channels have narrow Doppler spectrum, 那么因为呢缓慢变化的通道，它的都普勒的频谱呢就会比较的窄，that is small Doppler bandwidth， 也就是说呢具有一个比较小的都普勒的频宽。Then the coherence time and the Doppler spread are inversely proportional to one another。那么这个同调时间呢， 跟都普勒扩展，就会彼此之间互为反比。That is, TC is proportional to 1 over BD。也就是说呢 ，TC 是正比于 BD 分之一。A conservative measure of the coherence time is the so-called 50 percentile value, denoted by TC50, which is defined as the time separation for which the time correlation is equal to 0.5。那么这个同调时间的一个保守的测度呢，是所谓的50%的值啊，我们用这个 TC50 来表示。那么是定义成呢，当我的时间分隔开来，会使得这个时间的相关度呢，等于 0.5 的时候啊，这个时间的长度就是所谓的 TC50。It can be shown that reference 61。那么可以被证明呢，请看到这个reference 就是参考资料61。Okay, reference 61 is a book, Wireless Communications Principles and Practice. Okay, written by Theodore S. Rappaport, second edition, published by Prentice Hall in 2002。那么参考资料是61呢，是无线通讯原理以及实际。那么是第二个版本由这个 Theodore S. Rappaport 所撰写的书。那么是由这个 Prentice Hall 2002年所出版。Okay, who is Rappaport? 那 Rappaport 是谁呢？ Okay, he is a professor in New York University. 他是呢这个纽约大学的一个教授。Okay, his recent contribution is on the measurement of 5G channel model. 那这个 Rappaport 的教授呢，他近年来比较重要的贡献呢，就是对于这个 5G 通道模型的测量。Okay, TC50 is approximately 9 over 16 times pi times BD。那么这个 TC50 呢，就近似于16拍乘以 BD 分之9。Okay, next let us see section 4.5, classes of multi-path channels. 那么接下来呢，让我们看到 4.5 节，这个多重路径通道的类别。In the previous section, we talked about the intrinsic properties of multi-path channels. 那么在前一节，我们谈论了有关于多重路径通道的固有特性，或者称之为内在特性。In this section, we talk about how to categorize channels based on the relationship between these intrinsic properties and the nature of the signals being transmitted through them. 那么在这一节呢，我们要谈论的是有关于怎么样对于通道进行分类。那么基于呢这些通道的固有的特性，以及呢透过这些通道所传送的信号的天然特性之间的关系。This results in the following 4 classes of multi-path channels. 那么这个就导致了以下4种多重路径通道的类别。First, flat fading. 第一个平坦衰减。Second, frequency selective fading. 第二是频率选择性衰减 ，third fast fading。那么第三个呢是快速衰减 ，and the fourth slow fading。第四个是缓慢的衰减。OK，it is 25 minutes 啊，已经25分钟了。See you next time 啊，下次见。Goodbye 啊，再见。